Hi guys, today we're gonna talk how that I created this PS5 joystick simulations using Houdini and creating Vellum simulation from that. Here's the Blender file that I modeled in a few hours. The model is just a simple joystick from PS5. One thing that I worry about for the render of this joystick is about these are glass buttons, and that I need to create something inside, like this shell. This is a plastic and this is a glass button. The topology I try to make a little bit clean, more quad than triangles, and I create that from scratch using Google Images reference from the internet, and that's it. Here are another glass buttons. Inside we have this plastic white button, for example, if I use a white version for that. That's a simple model, and I try to organize here the names from the file, because I need to export Alembic and apply shaders in Houdini. I use the name of these objects to apply the shaders. In Houdini I use the Redshift for rendering. Here inside Houdini, guys, let me show the asset. I created the model in Blender, and right now I import the Alembic. Here's the overall project. I try to be more organized as possible to avoid the waste of time and later doing work. I just imported the Alembic that I created in Blender. Import Alembic, just a bit of cleanup work for the Alembic file. And here's the final file, the final asset in the start position of the simulation. Okay. After that, I start to create this first simulation, which is the rigid bar simulation. Just import the file. Actually, I create a collision before, because this file here is making impossible to do an RBD simulation. Instead, I create a convex hole of a VDB. I convert all the file to a simple VDB to create the RBD simulation more simple and fast to simulate. Instead of simulate all the file, all the geometry here, all the high geometry here, which is a waste of time, I just create this VDB simplified version. After that, I just create a material fracture, RBD bullet solver, and that's the final simulation of the RBD. Simple simulation, just simple unique piece falling on the ground. I using an AG8 for this guy, Rappi point cloud. I found this AG8 OTL in the Gumroad. I can share the link in the description. Just like a simple point deformer, this guy just transformed the RBD geometry, and that's it. This is the first step, simple falling RBD geometry. Okay. Let me check the jelly version. It's almost the same, but here is a Vellum simulation, a Vellum tetrahedron simulations instead of the cloth simulation. I imported the same VDB simplified version, doing a remesh, cleanup work. Let me see. Okay. A simple Vellum simulation to create this jelly behavior stuff. Jelly behavior from the PS5. Okay. After that, just clean up the tetrahedron, because this information, this geometry here, is not useful for making the point deformer, because here's a tetrahedron entirely of triangles Then I convert the stats to geometry and use the same node wrap to deform my original geometry. Like that. That's the second version. Let me check the cloth. Cloth simulation uses most the same network from jelly material. Just in the difference, this is a real cloth object. I simplified the joystick, the high poly geometry, in a low resolution geometry to make like this. It's a remesh version from the entire joystick, the PS5 joystick, and using the vellum glue to make all these boundaries of the geometry stick together instead of falling apart. I prefer to make the piece glue together and the simulation looks like that. This is a remeshed version. There's no apply shaders here. I need to deform the original high resolution PS5 geometry. Use the same node wrap to the original piece. That's the falling animation. That's cool. And here is the third version of the simulation. Actually, we show the RBD jelly version, and this is the cloth version. From the last one is just the yogurt material. This is a more complicated network because I need to split. I need to use the same DVDB collision. For this, I create the yogurt vellum grains, fluid grains. I fill the stuff inside the grain simulation. There's a lot of points here. Okay. And using another version from the original material to make like a cloth wrap around the inside of the glue yogurt, like a liquid. That's the look of the mission, the starting mission from the stuff. There's a cloth holding all the yogurt inside, the fluid inside. Here is the cloth holding the yogurt side, and here is the grains fluid emitter. After that, the simulation looked like this. It's impacting with the ground. Start to break some areas with glue here, and appears the yogurt inside. That's the simulation. A little bit complex network. That's the final result for caching geometry with the high-end version of the joystick and the cached version of the particles. Look like a yogurt. Okay. Let's show how the network, the render network in Redshift works. This version. I just create a simple camera here in object level. That's the camera. And import create a LOP network to start working in light and rendering Redshift. I import in here just let me check the jelly version here. I create a ground with a red color, enable subdivision here, and here I create a material just for the ground. And here is the material, Redshift material for the joystick. When I export the Alembic, it's most important to check, organize your file with each geometry piece with a unique name to avoid conflicting when apply the shaders in the Redshift. Okay. Let's check how the render is look. I using a simple texture, simple AGR texture here. Simple AGR texture. And this, let me check the look depth. It's faster rendering. Around, I think around 30 seconds to render, maybe more. No more or less than 1 minute. And that's it. This is the breakdown of the project. My main workflow just inside Houdini, model it in Blender, put this stuff inside Houdini and try to create the simulation. And render this stuff for compositing in the After Effects. That's it. That's it, guys. Here's the final result. Rendering Redshift, doing simulation in Houdini. It's a little bit of my breakdown, my process of work. The compositing I did in After Effects, just the final touch. That's it, guys. Thanks for watching. See you next time.